Hello guys, welcome to another video. I've been asked a couple of questions on if somebody can run through some basics on this. This is a Lucas Magneto. As you can see there, it is the rf4 model. This was fitted to quite a lot of the Fordson tractor range, mainly the Standards Model N and also the E27N. Later end of production of the Standards, more familiar on the E27N. Basically same fitment as the Bosch and the earlier Lucas. It's got the 4-bolt mounting on the base. We've got the impulse drive on the front. We've also got the advance and retard mechanism on the back of the Magneto, same as the earlier Lucas and also the earlier Bosch. By all means, this is not going to be a full-on instructional video of how to repair one or anything like that, but it's just a run over of the basics of what I've come across in my experience of looking at these. My Fordson that I have, my standard that you may have seen in the other videos, should have a Bosch type Magneto fitted to it because it's the earlier 1940 model. That's currently been reconditioned by a firm down in Sussex, I believe it is. It's Old Iron Engineering. When that comes back, I'll do another video on that, when we put it back on the tractor, and we can have a run through and see how that differs slightly from the Lucas one. But anyway, I'm just going to run over the basics with this one for you. So basically, we've got on the front, we've got the impulse mechanism. For anybody that don't know basically what this does, when the Magneto's obviously running at really low RPMs when you're cranking the tractor, this basically is a spring-loaded device. So as the tractor turns over, as you can see when you look at the centre shaft here, which is the bolt head here, and this is the drive dogs that engage with the tractor's timing gears, when you turn this, you can see that the centre is not turning, and basically that's under spring tension. So when there's so much spring tension on it, eventually it will flick over centre. Just see if I can do that by hand. I've only got one hand at the moment. There, you saw it flick and you heard it click. Basically what it does is it builds up a bit of energy in the spring. When it gets so much tension, it releases it and gives the energizing rotor a quick sharp flick. And at the same time, your actual distributor end of the Magneto will line up with the corresponding ignition HT lead, which will then give you a good spark in theory, if it works. This one doesn't, down that corresponding HT lead. So basically that's all the impulse does. As soon as the engine's got it's fired and the RPM's increased, the actual impulse drive locks out and it just becomes a solid drive straight through to the rotor. So basically what you've got, the impulse drive along the bottom of the Magneto is one shaft which comes out at the end where the actual points are, which I'll show you in a minute. That bottom shaft has a rotor on it, and that rotor is basically an energizing generator. So all it does, it makes a charge of electric current which is controlled by the points, and then in the top shaft, the top shaft doesn't actually really do anything other than the timing, but located in there is a high tension coil, and basically the rotor charges the high tension coil. As soon as the points open, there's a distributor in here which lines up a rotor arm to each corresponding HT lead and sends that impulse of electronic charge out of the high tension coil to your spark plug. It's dead simple. So anybody that has familiar with car electronics, with a traditional coil and distributor, it's basically the same idea. Instead of a voltage coming from your battery to your HT coil, we've got a generator in here that generates that charge. Does your high tension coil, same as your 12 volt coil or your 6 volt coil on your traditional type ignitions. Then you've got a distributor in here and a set of points in there. It's basic, really basic. So we're going to take off the spring clips here that hold on the distributor cap. It's just easier to flick them out with screws rather than it is messing about with fingers. So we're now going to take off the cap. Just bear with me 1 second. This one's a little stuck. It's been on here a long time. I'll just give it a little tease. There we go. So basically, HT cap, pretty much the same idea as what goes on in a traditional distributor on any motor vehicle. So you've got your pickup points here, and in the centre on these, where you normally have an electrode with your HT coil coming in from your coil, basically on this one you don't. There's just nothing there, it's a blank, but you've got 4 pickups. So obviously these are for your 4 cylinders. There's little grub screws. These grub screws basically just clamp in the HT wire. The wire just pushes in the back. You tighten up the screw. The screw has a sharp needle end on it. Basically it just pierces through the insulation of the HT wire to make contact to the electrode. So in the back of your Magneto you have a good old rotor arm, just exactly the same as what's in your distributor. Your charge comes up through the centre pole here. You can undo these. In there is a spring and also a graphite contact which runs down inside here, which connects to your HT coil, which is located behind it. Just while we're here, if anybody don't know what this is, basically it's where you lubricate the Magneto. A couple of drops of oil. It actually states on here, oil every 100 hours of running. It's just basically an oil can, couple of drips, that's all it needs. Don't go pouring loads in it, you're just going to drown it out. So as the Magneto goes round, your rotor arm here contacts with the inside of your distributor cap, which sends it to the according spark plug at the whatever bit of timing we're at. Now this is actually a gear wheel. Don't know if you can actually see, but there is gear teeth on the back of here. Basically this runs at half speed of your rotor, same as any distributor really, because at the end of the day your engine runs at half speed. I know it has 1 RPM, but when you actually look at it at a 4-stroke cycle, 1 revolution of the engine will only fire 2 cylinders. So every second rotation you get the other 2 cylinders. So that has to run at half speed of the engine. Otherwise you're going to have every plug sparking every quarter turn. But when if you're familiar with cranking over a fordson, you'll notice that the impulse only clicks twice per revolution. And that's because you only get 2 sparks per revolution. But you'll see when we take off the cap for the points what's going on. So basically behind this cap you've got a little arm here. Now this arm, there's one longer one. It's connected to this lever here, so you move the lever, which is connected to your advance and retard lever on the dashboard of the Fordson, and that moves this little crank arm. This locates into this fork here, and basically what you get is this locates into this fork here, and when the advance and retard is actually turned, you can see the points themselves will actually move around the center rotor, which basically alters your timing a little bit. Now if you have a Magneto that doesn't have an advanced movement mechanism like this one has, points gaps are crucial when it comes to Magnetos. Now the problem being, if you're not 100% familiar with it, you've got a rotor in here. Now on there is a lobed cam. Now you can see here, this part of the cam is thicker than it is here or here. Basically, when you turn the Magneto, when the cam comes round, it connects with this bit of a follower on the points. When it connects with that follower, it opens the points. Now you'll see when I open the points manually, you can see the follower move. Now when that cam comes round, it opens the points. Now if you have set your points correctly, i.e. the gap in between the 2 points here, these electrical connectors, what happens is they should be set on this Magneto roughly around 16 thou. So if you turn the cam until it comes round, connects with the lifter to open the points to the fullest position that this will actually lift them, then you set the gap on the points. Now basically all you have is this screw here and this screw here clamp the points to the actual backing plate. Now when you crack these off, you can move the fixed part, which is the top one. The bottom one moves with the cam lobe, but the fixed part, which is the top one, which is connected to the backing plate, you can move this in and out, which affects your points gap. Now if you have two excessive points gap, one, if you go too far, the points will never contact when they come off the cam, which you obviously need to make sure they are contacting. But the other thing you've got is when you have a greater gap, the simplest way to describe it is when this is the highest point of the lobe. We'll just put a little scratch there in the rust so we can see. Right, so we can see there, that is the highest point of the lobe. So obviously the follower raises up this part, gets to its peak here, and then falls down when it goes past it. Now if you have too excessive gap set, your follower is going to have to be closer to the rotor. So when it comes up here, it opens the points a long way. Now the problem being, if you set your points gap really wide when it's on the peak here, your points are actually going to open the second it starts touching this raised bit of cam, which then in fact, in turn, advances your timing, because your points are going to open earlier than what they should do, because it's making contact with the first part of the upslope of the lobe too early. So that affects your timing. And on the same instance, if you have it too tight a gap, it may only just contact right on the top of the lobe, which will then give you a retarded timing. So it's crucial that you set your points gap as per the manual for the Pacific Magneto. I'm pretty sure on the rf4s it's around 16 thou. So if you get that right, in theory your timing's got to be right. Now on these ones there is adjustment obviously by movement of the back plate, which on the other Magnetos, like some of the Y-cores, the A series Y-cores, they don't have adjustable timing. So it's crucial that that is right. So basically you get your points gap right. Obviously you need to make sure that these are clean. They need to be grease free, they need to be dust free. The easiest way to do it, I find, is just to open the points on spring tension, put a little piece of like wet and dry or really fine emery cloth in between the points, let the points close, and then draw the emery out. When you're doing that, it draws the dirt out, it draws the grease out, it draws everything out when you do that. Whereas if you put it in and rub it backwards and forwards, you're not getting rid of any bit of traces of grease. If you put it in and then draw it through, it's going to drag all that dirt and contamination out. But make sure you do both sides, top and bottom. So make sure they're nice and clean. Don't go mental, because you don't want to go wearing down the actual faces, so you're reducing the contact surface, and obviously then it'll adjust your points gap. So just a nice clean. Also in here we have got, this one's been bodged a little bit and it's had some solder repairs and stuff which aren't very good. But in there you can see, some of you might be familiar with them, it's a condenser. Exactly the same as what's in your distributor. You know, in your early like 70s, 80s sort of type cars, they have a condenser in there. Basically that is to build the charge from the high tension coil to a greater level. So if you're having trouble with Magnetos being good when they're cold, when you've had it warm, you stop it, you restart it, condensers are an absolute pig for showing the problems when they're warm. Now, if you find that when your Magneto's cooled down and it'll fire up no bother, there's a high chance that it's going to be your condenser that is the problem. Quite an easy fix. They're only fastened in with one little screw there. You take that screw out, it draws out, and it's just a case of reconnecting the wires there for where it goes into the high tension coil. Dead simple. It's worth having a go at it. You know, if you're confident with the use of a soldering iron and some basic settings, have a go at it. The replacement of that condenser, you're looking at somewhere between £5 to £10 for the condenser itself. If that does fix your Magneto, you're going to save yourself possibly, you know, thick end of 200, 300 quid on a recondition of the Magneto and a full rewind, what it might not necessarily need. Now, I know on this one, when I turned it over by hand, it is sparking at the points, but there is no charge coming out of the high tension coil. So basically, that's a good indicator that the high tension coil is a duffer. It's not building up any energy. It's not storing any energy. That seems to be the main problem with this Magneto. The other one that I've got, the Bosch, which is the earlier German Bosch that I've sent off for reconditioning, that's got the same problem. We've got charge coming from the low tension rotor on this main shaft here, which is working correctly. But we're not getting any charge out of the HT coil. Now, if I can undo these screws easy enough, which I should be able to because I've had them out once before, we can show you the high tension coil, which is located behind the points unit. So we'll just take out these 4 screws. They're normally quite easy to come out because most Magnetos are aluminium bodied, and you tend to find that these screws in these earlier days, they were made out of a lot better quality steel than what they are these days, which does help because they don't tend to stick as much, because obviously the aluminium and the steel they fur together, which causes you a lot of problems when you come to take little screws like this out. But if you do strip it and you do, you know, manage to rectify your problem, when you put it back together, put a little bit of grease on these screws. You know, you don't have to be copper grease, just put a little bit of just normal lubricating grease, just put a bit on, because you know next time if you come to take this apart again, you're not going to have any problems. It's going to come apart. Right, so here we go. So we've undone all the screws there. So we'll just give this a little tease out. Now, here you can see, obviously, the wiring is still connected there. That comes from the high tension coil through to the condenser, which is located there. Here we have the bearings that support the rotor shaft. As you can see, they're very dry, they're dirty, there's quite a lot of rust and contamination about. So if you do strip it, clean them out. Don't go crazy. A little bit of soft wire wool or a brass bristled wire brush, which is nice and soft. It isn't going to cause you any damage. You just want to go steady with them. As you can see here, you can see that the lobe is attached by a fastener through the center. If they are too worn, if you find it's got flats worn on it, it's not got the peaks still nice, or it's damaged, you can replace them easy enough. You just undo the screw, the drawer off. They're on like a little bit of a key. So you can see in there now you have the drive gear. This drive gear, like I said before, runs at engine RPM. It then drives the distributor gear, so that does a 2-to-1 reduction. So this is running at half speed. And inside in here, which is a bit hard to see, I'll just see if I can get some better light in there. It's a bit better. You can see the rotor, that's the generator rotor in the back there. When you're looking at it, basically what you've got is a dynamo, or like a stator. So you can see we have just to balance. That there is part of the rotor, and on the outside here is the magnet. That is the magnet round there. It's around both sides of the centre rotor. You see, there's another half there. That basically is what's generating your electronic charge. So the electronic charge comes from that rotor. Dead simple, you know, this is the most basic of engineering really. It's very clever, but pretty damn basic. So you need to make sure that first of all you're getting a charge from there, which needs to come then through your points, which we have here, through the condenser into the HT coil, which is located behind this gear. Now I think on this one I should be able to draw out the gear. I've had this off once before. Now these are timed. You'll see here there is a spot. That spot is a timing mark. Now there is, when I find it located, it should line up. So let's just turn the impulse. See if we can turn this nice and steady. We'll just lay it on its side. If we turn the impulse, that's going the wrong way. It's going backwards. It locks out on the impulse if you turn it the wrong way. You can see we've got to fight past the impulse. There we go. Turn it. Turn it. Turn it. Right. And you can see that one is slightly out of time. Basically this dot stamped into there, at the end of the shaft, that one there just locks the screw from undoing, and so does this one. But there is somewhere on here, struggling to find it, but anyway, that shaft lines up with that one when you get the dots right. Anyway, you'll see it when you tap. This one's been apart that many times, it probably hasn't been turned back up. I'm just struggling to see. There is a way that it times up. Anyway, you'll find out when you have a look. If you take this off, and like I said to you before, there is a contact electrode here. This contact electrode, it's mounted on a spring. You can't pull it out because the spring holds it in. But this contact electrode is connected to the output of your HT coil, which then contacts in the base of that bush. You can just about see where it makes contact, which is the back of the electrode top here, which is connected to your rotor arm. So that's all there is. There is no rotating shaft in the top. Some people think that there's two rotating shafts, but there isn't. There's only one rotating shaft. The top one is merely just a housing for the actual HT coil. So it's pretty basic. There's not a lot to know. Obviously, when you put these back on the tractor or any other vehicle, you have to time the magneto to the engine. Now that's another kettle of fish altogether. So we'll just put this back on loosely so you can see what's going on. That all goes back in. When you build it back up, don't forget to put a bit of grease on the actual bearings in the end shaft. It's just, one, you want to make sure it's lubricated, and two, it's good practice to make sure you lubricate everything back up when you put it back together. There's no point in having something apart and not doing the job properly when you're in there. Put some grease on, do a right job, it'll last forever. Well, I'll put it this way, it's seen out 70 years so far, so there's no reason why it won't see out another 70 as long as it's looked after. So when you come up, fasten it back onto your tractor. Now as it comes to actually timing it up with the engine, there's a really simple thing with these, because at the end of the day you have adjustable timing due to that. So the Magneto only needs to be timed and connected to the engine correctly as long as you've not had this impulse shaft off, because that is timed to the Magneto. That bit, I don't know how to do it. I'd have to look at a book. I have no idea. I have no intention on ever taking one apart. If it gets to that stage, it's going to a Magneto specialist. But basically when you put this back into the engine, you can only have it, in theory, 4 ways, because you've got the coupler, which obviously can go in one way or the other, which would give you 180 degrees incorrect. But because our top shaft turns at half speed of the bottom one, that multiplies it by 2, which gives you 4 incorrect ways to put it in, which is right, because at the end of the day we're in a 4-cylinder engine. So the way to do it, if you've taken a mag off and you're simply putting your mag off, having a look at it, or changing it with another mag and putting it back together, the easiest way to do it is to remove your distributor back in while the Magneto is still connected to the tractor. Have a look in the back of your distributor cap, locate which lead is cylinder number 1. So we'll say, for argument's sake, this is number 1. So we know when that is placed on the back of the Magneto, it's up here. So think of it as a clock face. We're roughly about the 11 o'clock mark. So what you need to do, turn the engine over till the rotor arm comes round to the 1 o'clock mark. Then you know, leave your engine where it is, don't turn it again. When you put this Magneto back on, no matter how you've turned it round, whatever, your rotor arm needs to be roughly at 11 o'clock. Because it can't go in any other way, because we've got the dog drive, which is only a straight slot. It can only go in 50-50. So in theory, as long as that's pointing up there, when you take it off and you put it back on, it's got to be right. Same again, if you're changing Magnetos, turn your original Magneto that is on the tractor round by the hand crank, wind it over till you get to it's firing at number 1, remove your Magneto. Before you put your new Magneto on, turn it by hand until your rotor arm's pointing at number 1. Put it back on, Bob's your uncle. Dead simple. There's nothing hard, difficult or awkward about it. You should be able to manage it. So that's a brief insight of a Lucas Magneto. The really basics. I'm not claiming to be a Magneto engineer or be a specialist in it. Just stuff I've learned as I've been going along, and as I've been looking into it to see whether I could get this one to work. Fortunately, high tension's coil's gone, and that's beyond me. It wants a full rewind, so it wants a full recondition. There's no point just doing one. You've got to strip the mag to do the high tension coil, so you might as well do the rotor at the same time. Put new points in, new leads, it'll be like a new one. Anyway, don't forget to like, subscribe, hit the bell so you get further notifications for further videos that we'll be doing. It's all going to be pretty much tractor orientated one way or another. We have got a project coming up soon where I will be building a trailer. The trailer will be for going on the road behind a van or a Land Rover or such. It basically for carrying the Fordson, as my van will not carry the Fordson, it's too heavy for it. So we're going to make a twin axle plant style trailer. There will be videos, photos and updates on that as we go along. But thanks for watching, guys, and hope to see you all back again. And don't forget to like and subscribe and keep in touch. Any comments would be appreciated, any feedback. Thanks a lot. Ta-ra.